Hello everyone. So we'll be solving find the longest balanced substring of a binary string. You are given a binary string S consisting of only zeros and ones. A substring of S is considered balanced if all the zeros appear before ones and the number of zeros is equal to the number of ones inside the substring. So we have to return the length of the longest balanced substring of S. Okay. So what does the question states that we have a string s, okay, and a substring of this binary string is considered to be balanced if number of zeros is equal to number of ones and all the zeros appear before my ones, right? So if I take the example, the first example is 0 1 0 0 0 1 1 1, right? So can we say that this is a valid substring? Why? Because all the zeros appear before ones and number of zeros is equal to number of ones. What is its length? Length equal to 2. Okay. Now this is also a valid substring. Why? Because all the zeros appear before ones and number of zeros is equal to number of ones. Okay. And length is equal to 6, right? So we have to return 6 here. Why? Because that will be the longest balanced substring, right? So how do we first of all, let us see what the substrings, when do we call the substring as by balanced substring? Okay, let us see, we have, if we have this example. Okay, so if I'm considering any substring to be balanced, okay, if I'm considering any substring to be balanced, I have to check. Okay, if I'm considering any substring to be balanced, I'll have to see, there has to be some number of zeros. There has to be some number of zeros before ones, right? There has to be some number of zeros before ones, right? So how do we apply that? And always my substring will start with 0. Okay? Start with 0, right? And it can be of any length, and at a time my substring can be of 2 length minimum. Okay, because there has to be equal number of zeros and equal number of ones, uh, if at all it has elements, or 0 will be the length. Okay, so what data structure can we use to keep my zeros and then check if after that any number of ones is present or not? Okay, so we'll be using a stack data structure. Okay, we'll be using a stat data structure. I'll quickly just explain the algorithm first. So what is the algorithm? What we are going to use is, we'll keep a stack. Okay, and since we already discussed that for a string to be valid, all the zeros should be before ones, right? All the zeros should be before ones. So for that, what we can do is, if my I will traverse in my stack. Okay, I will traverse in my stack, and if my character at ith index is equal to 0, right? If my character at ith index is equal to 0, what I can do is I can just push it in my stack. Okay, I will just push it in my stack and my counter remains 0. That is the length of the valid substring. Till now we don't have any valid substring, right? And if at all there is 1, if at all, if s of I is equal to 1, okay, if at all we get a 1 at any index, what we can do is we can see. Okay, we will check if my stack has zeros. Okay, we will, if we get 1 at the ith index, we will check if my stack has any number of zeros. That is, if there are some number of zeros in front of this one. Okay, and we'll try to pop those zeros. Okay, so I will quickly take one example and explain the intuition with you. Okay, so we have the stack. So what I'm trying to say is, first I'll go to the first index. Okay, it is 0, right? So I'll push it in my stack. Hmm? Then I'll go to next index. I'll see. is my stack empty? And every time I'm getting 1 here, I will just pop out all the zeros from it and keep updating my counter value. Okay, I'll keep updating my counter value. So let us see here. We went to 0, we pushed it inside our stack. Okay, we went to 1. Okay, so 1, we have 1 s of I equal to 1. Now we'll see, is my stack empty? Are there any number of zeros before this one? Yes, there are number of zeros. So what I can do is, I will just update my counter equal to 2. Why? This is my length of valid. Till now, the valid substring what I got, that is 2. Because minimum length is 2, right? We'll add 1 and 2 to our length. So we'll add this and we'll update the counter. And we'll also have a max value, in which I will update the max value also. That will be the maximum length of valid substring till now. Okay, so we took this, we'll pop it out. So now the stack is empty. Okay, we our stack is empty. We went to again the next one. Is it 0? Yes, push it. Next one. Push it inside a stack. Next one, push it inside a stack. Okay. So now we are at 1 again. And we can see here that this is another case where 1 can appear many number of times, right? 1 can appear many number of times. So from here, we'll run a while loop. Okay. We'll run a while loop, that from this index, we'll run a while loop, and we'll keep popping out the zeros in pair. Okay, we'll keep popping out the zeros in pair, right? So we'll run a while loop till my j is at ith index, and till my j is less than n. I'll run the while loop and I'll check. i'll keep popping the I'll keep popping the zeros from my stack, and I'll keep updating my counter as 2. So if we see the code, it will be more clear. So this is the code. So we took the maxi as min, that is the answer variable, and we have a stack. Okay, we have a counter variable equal to 0. So what I'm doing is, I'm traversing inside my stack. So the first step is, if my s of I is equal to 0, then I'll simply push it inside my stack. Okay, the counter here stores the length of the balance substring till now. Okay, till now, whatever is the balance substring. So if my s of I is equal to 0, I'll simply push it inside my stack, and every time I'm pushing zeros, my counter will be initialized to 0. Right? Sorry. Yes, my counter will be initialized to 0. Why? Because I'm considering a new valid new valid substring. Okay, new valid substring. So else, I'll go to the else part and check if my okay, so now we have a 1 over here. Okay, so now we have a 1. I'll check if my stack is empty. That is, if there are no zeros before this ones, I will just continue. Else, if my stack is not empty, that means there are some number of zeros inside my stack. What I can do is, I can keep a pointer, and till the time from this index I am getting ones, I can just uh, check this if my stack is not empty, and if s of j is equal to 1, what I can do is, I can just do counter plus 2, that is the valid substring length, j plus plus, and I'll store it in max value, and I'm popping out the element, right? And again, I'll flush out all the stack values, that is the extra zeros we have before a 1, so that I can consider a new substring ahead of it. Okay, and if in max value is equal to min, then I'll return 0. That means there were no valid substrings. Else, I will return maxi. If I try to submit this code, this gets submitted.